So in problem number 12, we have a piece of cardboard that's being folded up to form a box. We're told that the one end of the cardboard box is a square. So it would be like x by x by x by x, with it being h for this side. You can use whatever you wanted, but you should know that the volume of a box is length times width times height. So in this case, it's x times h. Or we could just write it as x squared h. But when we look down here, it says it wants the volume only with x's. Hmm. Well, right now we have it with x and h. So in other words, we need to somehow represent h in terms of x's. Well, we know our perimeter is 24 of our cardboard. Our perimeter would be all the way around our rectangle. So we have x, x, x. So we have 4 of the x's here, plus you'd have 4 more of the x's in the top. You have an h on the right and a second h on the left. So you get 4x on the bottom, h on the right, 4x coming back on top, and h on the left. So we get a total of this. So how does this help us? Well, if we go ahead and try to get h by itself, I could subtract an 8x from both sides and then divide by 2. I could go ahead and take this and plug it in right here for h. And so if I distribute through, I get then my volume only in terms of x. Now, before you graph this, because it says to graph it to find our maximum, you would want to go ahead and think about what is your domain. That's the numbers you're putting in for x. Well, you know you can't have a negative side length, so x and h can't be negative. Well, that means x has to be greater than 0. But you might want to consider the situation. If x is really, really, really big, then that means h would be really, 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 really small. So essentially, you can look at the other extreme where h, which is this here, has to be positive because it can't be negative. So basically, you want to set it equal to 0 or solve this inequality. In either case, you end up getting 3. So it has to be bigger than 0 but less than 3. So your domain is this. That comes into play when we graph it. So go to your y equals, put this in your y equals. And then we're going to have to go and hit your table feature, or not table, window feature on your graphing calculator. So here's your window. We know we can't be negative. We know the biggest x can be is 3. And your y min, y is the output, which would in this case be your volume, and you can't have a negative volume. You would know that that would be 0. Oh, and this is supposed to be y max down here at the bottom, not x max. The question is, you don't necessarily know the maximum for your y value. So you're going to probably have to play around with it, putting something in here, hitting graph to kind of see what makes sense in the context of our problem. I chose 20 after some playing around. We now need to go ahead and find our maximum. Now that we have our graph, we can go second trace, which is our calc, and down to 4, which is our maximum. We want to be to the left of where it crosses, so it is. I'm going to hit enter, and now I'll be to the right of where it crosses, which I am, and I'll hit enter. And I don't want to go ahead and guess, so I'm going to hit enter, and I get my maximum right here. So as we look at this, we want to find the point at which gives us the maximum. That would be when x is 2, our y, which is representing our volume in our problem, is 16. So if you were looking for not only the point, you would then also be maybe looking for the dimensions. Well, if x is 2, you could then work backwards up here if x is 2, and you could find h, and then you would have the size of your uh, box that would give you the maximum volume.